We use the second formula here, huh? Wait.
Yeah.
And
I got
no, sorry. Where's the formula? Formula sheet here. The distance is 10 meter. The time is 2
yeah.
seconds. So we have 10 equal 1 half a times the square of 2, 4. 4 over 2. Let's try that formula. Where's that? And then you can calculate the exertion. X equal x0 plus ut plus 1 half at squared. X0 here is 0, initial velocity also 0. We have 10 meter equals this one plus 1 half acceleration times the square of 2. So acceleration is 10 over 2, huh? Which is 5. You're right. It's 5 meter per second square.
So like, how do we draw it? And do we need to
Determine the
draw
constant
it?
exertion. The first question A is the exertion, which is 5. Done, huh? Determine the sprinter velocity after 2 seconds. Displacement. Cái đó mình sẽ làm sao? Mình làm câu B trước đây ha. After 2 seconds, the velocity, we use the formula 1 here. Velocity is initial velocity plus acceleration time, huh? So the velocity after 2 seconds is the initial velocity plus acceleration time, which is 0 plus acceleration is 5 and the time is 2 seconds. So the answer is 10, huh? 10 meter per second. Rồi, đây là câu B xong nhé. Determine the total time needed to run the full 100 meter. We have known that the time taken for the sprinter to run the first 10 meter is 2 seconds. It is already given in the statement of the problem, huh? So now we only need to calculate the times that he run the last 90 meter with the constant velocity, which the constant velocity is this value 10 meter per second. So the time to run the last 90 meter distance is simply 90 meter divided by this constant speed 10. We have 9 seconds. And then add this 9 seconds with the initial time 2 seconds taken to run the first 10 meter, we get the total time, which is 11 seconds. Okay?
Yeah.
Và thầy xóa đi, mình viết lại để nhớ nhé. Viết ngắn gọn như vậy thôi. Cô viết tóm tắt lại 3 cái câu vừa rồi đi, sau đó thầy bày mình làm câu đi. So to draw the graph correctly, the parabola, you need to identify the time taken for the runner to run. Only in the first 2 seconds, the distance that she or he ran was 10 meter. This value is 10. So it's a parabola starting from 0 and go to 10 after 2 seconds, huh? Like this, 2 seconds. And then it takes 9 seconds to cover the distance of 90 meter. The remaining distance is 90 meter up to 100, huh? The total distance is 100. And the time, the final time is 11 seconds here. We have just calculated, huh? So C will complete the run in 11 seconds. So the next part of the graph is a straight line indicating the constant speed from 2 seconds to 11 seconds, straight line like this. And this is a smooth transition from the parabola, the parabol to the straight line. Okay. Đó, cách làm như vậy nhé.
Yeah.
So your answer, the first interval from 0 to 5 seconds, velocity is 0, and then determine the velocity of the end, at the end, okay? Tức là mình tính là velocity up 10 seconds chứ không phải là ở giữa đâu. From the second segment of the graph here, this segment, we see that the acceleration is 4 meter per second, per second square, 4 meter per second square. So we simply just use the formula v equal u plus at to calculate the velocity at the end of the second segment, which is 10 seconds, which means the time here is the interval, not the value 10. It's 5 seconds, the time difference between 10 and 5. Okay? 5 second interval. time the acceleration is 4 meter per second square, 4. So the answer is 20.
Yeah.
The answer here is 20. Okay. Similarly, please continue doing the rest of the problem. Yeah, the third part is also a zero acceleration, constant velocity of 20 moving upward. And the last part, it decelerates, it slows down. Similarly, now we have a negative acceleration of negative 4 meter per second, and it slows down to 0. The final velocity will be 0.
Yeah.
Because initial velocity is 20, acceleration is negative 4, which means the velocity decreases by 4 meter per second every second, from 20 to 16, 12, 8, 4, and 0. It takes 5 seconds to slow down to 0 from 20 with the acceleration of negative 4. So the final velocity is 0. The elevator comes to a stop, the destination, like 20 floor or something. Now please plot the velocity graph as a function of time. You now have those values, 20 and 0.
So it's just drawing like straight lines.
Yeah. For example, during the first 5 seconds, the elevator hasn't moved yet, so it's simply just a 0 horizontal line.
Do we have to connect the from the first 5 seconds to the 10?
You do need to connect those parts of the graph indicating a smooth transition of the speed, the velocity of the elevator. It cannot suddenly change the velocity like from 0 to 5 like instantly. It cannot do that. Okay, it takes time for the change to happen. Okay, it speed up here during the next 5 seconds, from 5 to 10 seconds. Correct? Yeah, this is the correct answer. Well done. Question B. Determine the displacement of the elevator above the starting point at the end of each 5-second interval. Okay, do you remember what I have told you like 2 times? How do we calculate the distance that the object travels from the graph of velocity? How?
The area.
Yeah, exactly, area under the graph velocity.
Yeah.
And in this case, we only have the positive part moving in one direction only, which is upward.
Yeah.
And not it does not involve any negative part.
Wait, for from the 10 to 15 seconds, is it the area of the rectangle? Is it
we
0?
calculate the determine displacement. Okay, for example, at 10 seconds here, 10 seconds, we need to calculate the area of the triangle, the first triangle.
Yeah.
And at the end of 15 seconds, we need to add the sum of the 2 areas of the triangle and the rectangle. Yeah, because the question is displacement, meaning compare the position with the starting point. So we need to add the 2 displacement together.
But it's like from 10 to 15. So is it just like
10 to 15, it is a constant velocity. So the distance moved during that time from 10 to 15 is simply just the constant value, 20 times the time. 20 times 5, 20 times 5 is 100. So the displacement above the starting point. Yeah, I think that you need to add the area of the rectangle with the previous triangle. 100 plus 15,
Okay.
Let's check. Right, so okay, the total distance moved by the elevator 200 meter. 200 meter is quite tall tower building.
Yeah.
Cái tòa nhà 81 tầng ở thành phố Hồ Chí Minh nó cao bao nhiêu nhỉ? Thầy nhớ hình như tầm khoảng hơn 400 mét hả? Rồi. Plot the displacement is a function of time following graph. Con phải xem đoạn nào là parabola, đoạn nào là straight line ha. The graph of displacement is a parabola concaving up when it accelerates, when it speed up, which is the second segment.
Yeah.
And then the graph becomes a straight line going up, positive slope, when the velocity is constant during the third segment from 10 to 15 seconds. And lastly, the last segment, when the velocity decreases from 20 to 0, it has a negative acceleration. We know that the graph of a quadratic function ax squared concave up in the case that the coefficient a is positive, and it concave down when a is negative. So our graph will be like this, and then straight line, and then concave down. Okay. Your task is to draw it accurately with the values, the accurate value of the displacement travel by the move by the elevator.
Okay. Hey, can you keep the hey, quay lại yeah.
Okay, so during the first one is was still stationary, so zero displacement. Then it goes 50 meter here, the distance 50. During the next 5 seconds, 50. Yeah, this part of the graph is correct. And then constant velocity, so the straight line here is correct. Up to 150, 150 meter distance. And lastly, it does not go to zero displacement. It continue moving, so it can and the final distance is 200, so it can cave like this there. So it form a continuous graph, a beautiful smooth transition here for the straight line part, and then another smooth transition here for the final parabola. Okay. Rồi cái đoạn cuối này nó làm parabola, nó concave down như vậy nhá, concave down và nó đến 200 m, chứ không phải là nó đi về cái vị trí xuất phát, nó không rơi xuống vị trí cũ nhé. Rồi. Có 5 thi thì người ta chấm cái smoothness, tức là cái smooth transition này người ta chấm kỹ, nhưng mà có 5 thì người ta cũng kiểu du di bỏ qua, tức là nếu mình vẽ nó hơi gấp khúc, nó không được đẹp lắm thì người ta không bỏ qua. Rồi, còn ít thời gian, vài phút nữa thì cũng không đủ để làm bài nữa ha. Thôi hôm sau thầy sẽ nói tiếp bài nữa, nó cũng hơi khó. Đâu rồi? Này click nhầm vào chỗ nào, nó bị mất chỗ đó này. Kinematic practice problem. Hôm sau mình sẽ làm tiếp bài hơi khó nữa. Thầy sẽ giao cho con một số cái homework vừa thôi, không khó lắm ha. Rồi mình nghỉ sớm vài phút nha.
Bye
bye con.
Cảm ơn.